Hi guys, today we're going to be going over electrophilic substitution, in particularly the nitration of benzene. Now this is one of the two electrophilic substitution reactions you need to know about for A-level chemistry. Now substitution is when one group is replaced by another group on a molecule, and today we're looking at when a nitro group replaces another group. Now this creates a nitro compound, and the uses of nitro compounds can be to create dyes, can also be to create pharmaceuticals, and also to create explosives, which are explosive when heated. Now TNT is an example of an explosive nitro compound. It contains a methyl group and 3 nitro groups, and when heated, TNT explodes. Now we're not going to be going over electrophilic addition for benzene, because if you were to do this with benzene, then the delocalized ring of the benzene molecule would actually be destroyed. Now you need to know the structure of benzene properly to be able to understand nitration of benzene and how it works. But with a benzene molecule, we have 6 carbon atoms, and each carbon is bonded to a hydrogen atom. Now you're probably wondering, carbons normally bond to 4 other atoms, or they create 4 bonds. But in a benzene molecule, they only create 3 bonds. This means there is a delocalized electron for each carbon atom. So that means there are 6 delocalized electrons in benzene, which creates that delocalized ring you can see in the middle of the molecule. Now this delocalized ring is very, very important. If you were to just add something to the benzene molecule without taking something back away, then what actually happens is it destroys this delocalized ring. This is because one of the electrons from the delocalized ring will be used to create a covalent bond. So now there'll be only 5 delocalized electrons in the middle of the benzene molecule, which will actually create a positive charge in the middle of the benzene molecule, which will destroy the ring. So I'm representing the molecule with an X, and if we added this, what's actually going to have to happen is the hydrogen is going to have to go to reform this delocalized ring of electrons. And if you don't understand this too much, don't you worry too much, because it's not a vital thing to remember. It's just good to recognize and understand. Now the first step to the nitration of benzene is actually forming the electrophile. Now remember, an electrophile is an electron pair acceptor. It's got a positive charge, so it can accept that negative charge from the electrons. Because remember, opposites attract. So we have a concentrated nitric acid and concentrated sulfuric acid. These react when warmed to form a nitronium ion, H2SO4- and water. Now this nitronium ion is actually going to be our electrophile for the reaction, because it has a positive charge and it can accept an electron pair. Now like I said, we have to warm the concentrated nitric acid and the concentrated sulfuric acid. Now the second step is actually the mechanism itself. This is the fun part of the reaction. So we start off with our benzene molecule, which you should know what the structure is by now. If not, definitely research it, because you need to know. And we've got our nitronium ion. Make sure to put the plus sign above the nitrogen, because that's actually the part that has the positive charge, the nitrogen atom. The electron dense region inside the benzene actually attacks the positive nitronium ion. Now the nitronium ion is actually bonded to the benzene molecule, but it's actually destroyed the delocalized ring of electrons in the middle of the benzene molecule, because now one of the electrons has gone into creating the bond with the NO2. Now as you can see here, I've demonstrated a horseshoe shape for the electron dense region now, because we've actually lost an electron. So this electron dense region has been broken, so it's not a full circle anymore, it's been broken. And I've put a positive charge to show that it's now a positive region. It's not a negative region anymore. Really make sure that with the horseshoe, it does not extend carbon 1 or carbon 5. But yeah, don't extend the horseshoe beyond the carbons directly adjacent to the carbon bond in the NO2 group. I'm also showing the hydrogen atom. Now this was already there. It's really important to recognize that. I've not just added a hydrogen atom to this benzene. It was already there. I'm just showing it. because remember each carbon is bonded to one hydrogen. So yeah, now this carbon that's bonded to the NO2 is actually forming now 4 bonds, which it should be, but not in a benzene molecule. So it's forming 4 bonds. So one of these has to go, and it's obviously the hydrogen, because we've added the NO2. There's no point getting rid of it again. So we're going to get rid of the hydrogen. So now the hydrogen is actually giving the electron that it shares with the carbon back to the electron dense region in the middle. Now this reforms the electron dense region in the middle of the benzene molecule and forms our nitro compound, but also forms a hydrogen ion. Now this hydrogen ion is really good because it regenerates the catalyst by reacting with the HSO4- ion. It regenerates the H2SO4 catalyst, which is our acid. So yeah, that's everything for the nitration of benzene. So yeah, now I'm going to be going over the 2 main steps to the nitration of benzene, which is forming the electrophile and substituting mechanism. So yeah, we're going to warm the benzene with concentrated nitric acid and concentrated sulfuric acid, as we know. And like I said, our H2SO4 acts as a catalyst, and our NO2 plus is our electrophile. So H2SO4 plus HNO3 gives us HSO4 minus plus NO2 plus H2O. Now our NO2 plus, our nitronium ion, is our electrophile because that's a positive charge and it accepts a pair of electrons. Now we're going to be going over to our substituting mechanism, which uses our electrophile, our NO2 plus. So we've got our benzene ring, like I said, and we've got our nitronium ion. Don't put the positive charge next to the oxygen, put it above the nitrogen because that's the place with the positive charge. Now our electron dense region attacks the nitronium ion. Now this destroys our electron rich region in our benzene molecule, which gives it a positive charge. We've also shown our hydrogen atom. Now hydrogen's going to go, okay, you can have my electron to make you negative again. So what it's done is the hydrogen atom has detached from the benzene molecule, and it's now formed a nitro compound with our NO2 group, but also our hydrogen ion. Now our hydrogen ion is going to react with our HSO4 minus to create our H2SO4 catalyst. Now it's really important to know that that's how the catalyst is formed, because catalysts are regenerated by the end of the reaction. Now our next thing is mononitration. Now mononitration is when only one NO2 group is substituted onto the benzene molecule. And now for mononitration to occur, you have to keep the reaction below 55 degrees. If the reaction is above 55 degrees, then more than one nitro group will be substituted onto the benzene molecule, which we don't want if we want just one nitronium ion substituted onto the benzene molecule, and this is polysubstitution. So yeah, make sure it's below 55 degrees. Now, thanks for watching. I really hope you find this useful. If you did, make sure to subscribe, make sure to comment, make sure to like this video, make sure to share it with your friends if you think it's helpful, and I'll see you next video. Bye bye.